Hi everyone, and welcome to section 9.5, which deals with dividing square roots. So this section we're just going to go over dividing square roots and rationalizing one or two-term denominators and what that even means. So let's get started. Okay, so these are some simple division problems. So first thing that you would do if you have a radical, you simplify it, yeah? So this is 9 times 6 over 6. Square root of 9 becomes 3, and then you have a root 6 inside over 6. But we're not done here because 3 divides into 6 twice. So your final answer is root 6 over 2. Okay, how about this one here? This looks interesting. So you can think of it as two ways. Because this is a two-term numerator, you can write this as 6 over 12 minus square root of 24 over 12. That's because that's property of fractions, right? Now, square root of 24, what is that? That's 4 times 6. So then this becomes 6 over 12 divides, simplifies to become 1/2, right? Minus, and then 24 becomes 2 root 6 over 12. But then this part cancels. 2 goes into 12 6 times. And your final answer is 1/2 minus square root of 6 over 6. All right. Quotient property of square roots. Quotient property basically is saying if you're taking the square root of a fraction, you can also rewrite it as square root of the numerator over square root of the denominator. So like see, for example, here, it's already separated, so I can reduce this to 9 times 3 over square root of 25 times 3. And then this becomes 3 root 3 over 5 root 3. The root 3's are the same, so they can cancel. And your answer is 3/5. Okay. What else? We have here 48 over 108. So if we used it in the other way, you could rewrite this as 48 over 108, which is the same as saying, don't forget your square root, 3 times 16 over 3 times 36. So that cancels the 3's out. And then that's square root of 16 over square root of 36, which just becomes 4/9. I mean, so you can go this way, or you could have just simplified it and canceled out what was in common. Now that property actually becomes more helpful here, because you can write this as one radical, 6y to the 5th over 2y. And now this cancels. 2 goes into 6 3 times. Y, 5, y to the 5th power divided by y is y to the 4th power, right? Because 5 minus 1 is 4 today. So then you just get square root of 3y to the 4th. But then this y to the 4th comes out, y squared square root of 3. Okay, so then similarly here, we have the square root of 72 over 162. And then here it's x cubed over x, right? X cubed over x. Now, can we simplify this? Okay, so well, I know that at least 72 and 162 are both even. So let's go ahead and divide top and bottom by 2. Divide by 2, divide by 2. You can, that's a division symbol by 2. Then you can reduce that to square root of, half of this is 36. Half of this is 81, right? And then x cubed over x, that just becomes x squared, right? Now, square root of, you can write this as, this is the same as saying, same thing as 36x squared over 81. I just want to make sure that it's clear. These two, you can write them the same. It comes out to the same thing anyway. So anyway, I'm writing it this way so that you can see that the x squared, it can come out and it becomes x, because square root of an x squared is just x. And then here you have square root of 36 over square root over 81. But if you think about it, that's square root of 36 over square root of 81. So that's just what? 6 over 9. And then don't forget your x. This reduces to become 2/3 x. Okay, so let's do another one. So 147 over, 147 AB to the power 8 over 3a cubed b to the power 4. So let's see what happens, yeah? So, sorry, excuse me. 147 divided by 3 just so happens to be 49. Oh, I don't know what I did here. Okay, yeah. So this becomes square root of, so the numerical part becomes 49, sorry. And then here, a to the first power over a cubed, 3 minus 1 is 2, but it stays in the denominator. So you can write it this way, a squared. And then a b to the 8th over b to the 4th. Well, 8 minus 4 is 4, stays in the numerator because that's where the largest number is. So then this is just square root of 49 b to the 4th power all over square root of a squared. That's just going to be 7b squared over a. And that's it. So next thing we want to learn is rationalizing the denominator. So, so the first thing that we do is convert a fraction to an equivalent fraction with the radical in denominator is called, we just multiply top and bottom by the radical itself. And because you know that any number, the square root of a number squared, that's just going to be the number itself. So we're going to use this. Okay, so yeah, so it's simplified if there's no perfect squares, no fractions, no square root. So let's see here. We have 4 over root 3. To rationalize the denominator, we're going to multiply root 3 over root 3. That's going to be 4 root 3 over, and then these cancel out, right? So that's just going to be 3. And then this one here, we have 8/3 root 6. I mean 8, yeah, 8 over 3 root 6, negative 8 over 3 root 6. So we multiply top and bottom. We could just do root 6, or we could do 3 root 6. Let's just do root 6. Keep it simple, right? Just so root 6 over root 6, you're going to get 8 root 6 on the top, negative, of course. And then on the bottom, you have 3 times 6, right? And that's going to be 18, okay? 3 times 6 is 18. And you can reduce top and bottom by 2, so that becomes 4 over 9. So this is negative 4 root 6 over 9. All right. How about this here, square root of 5 over 12? So that's the same thing as square root of 5 over square root of 12. And then multiplying top and bottom by square root of 12. That becomes what? So then on the top here, you have square root of 60 over. And then on the bottom, you have just 12, right? Now, what are the factors of 60? So the perfect square that divides is 4. 4 times 15, right? So you get square root of 4 times 15, which is 60. Excuse me, over 12. Ooh, that becomes 2 root 15. I'm so sorry. Over 2 root 15 over 12. And you divide top and bottom by 2, you get the 2 canceled out on the top. You get 15, square root of 15 over 6. Sorry about that. Okay, so now we have square root of 7 over 18. We can write that in this form. Multiply top and bottom by root 18. And then that becomes, on the top, 7 times 18, excuse me, is 126. So that's 126 on the top here. And then 18, square root of 18 times square root of 18 is just 18. And I don't, is there there is a square root that can come out of 126. 126 is divisible by 9. That's actually 9 times 14. So that'll work for us. So that reduces to 3 square root of 14 over 18. Or just 3 divided top and bottom by 3. Square root of 14 over 6. Okay. what if you have a denominator that's two terms? So we use this property of difference of squares, right? We used this earlier. So basically what we do to rationalize a two-term denominator is you multiply top and bottom by we call it the conjugate, right? And remember, the conjugate is basically the same two terms, but change the sign that's in the middle, okay? So you'll see, so in order to do that, so the conjugate to 4 plus square root of 2 is going to be 4 minus square root of 2 over 4 minus square root of 2. So that's what we're multiplying by. So on the top, you have 4 times 4 minus root 2. And on the bottom, because this is, a plus b, a minus b, that's going to be 4 squared minus square root of 2 squared. So then on the top, you distribute. So that would be 16, or actually, let's see what this, if this can reduce at all. It might. So I'm going to actually wait on distributing because I want to see if I can cancel something out. So let's go ahead and find out. So 16, this is going to be 16. This cancels out. This is 16 minus 2. So then that's 14 on the bottom. And as suspected, so divide top and bottom by 2. This reduces to become 2. And then the bottom becomes 7. So now I can distribute. So then I get 8 minus 2 root 2 all over 7. And that's fine. Okay, let's do another one. Conjugate of 2 minus root 3 would be 2 plus root 3. 2 plus root 3. Okay, root 3. And then on the top, we get 5 times the quantity, 2 plus root 3. And then on the bottom, we would do difference of squares. So 2 squared minus root 3 squared. So that's just 4 minus 3, which is 1. Okay, so then, so this is 4 minus 3, right? Because this cancels, and then that's equal to 1. So you get basically, since the denominator is going to end up being 1, you would just write 10 plus 5 root 3. You would distribute that 5 there. Okay, what about something that looks like this? This is crazy looking. So let's multiply by its conjugate. So the conjugate is just square root of u plus square root of 6. Square root of u plus square root of 6, like that. Okay, so fine. So on the top, we have root 3 times the quantity square root of u plus square root of 6. And on the bottom, you have difference of squares. So square root of u squared minus square root of 6 squared. This is supposed to be a u. It looks like a w. So let me fix that. This is a u. Okay, so then distributing on the top. So this is square root of 3u plus square root of 18, which is going to be simplified. And then on the bottom, you have u minus 6. So on the top, 18 reduces to 9 times 2. Factors into 9 times 2, which becomes 3 root 2. So on the top, you have square root of 3u plus 3 root 2 all over u minus 6. And we can't do anything else, so we leave it like that. Okay, so that's it for this section. One more to go. You can do this. Good luck. Happy studying. And I guess I'll see you on the next video.